weldments. So, a little introduction here. I'm based out of Grand Junction, Colorado. So I just came for this morning just for this presentation. So appreciate you guys' time here. At Dr. Systems, I'm an application engineer, and I do a lot of our teaching, our pre-sale, some of our consulting services as well. But most of my time is spent on our I also do a little bit of simulation and CFD for computational events. Some more interesting stuff about me, like biking and skiing and rock climbing, and then my normal boring corporate interest becomes one of the work here. So try to spice up a little bit, make it as interesting as we can while we stare at the screens. How many 14-years you been on? Just two. Just two. Ask me in a year. Okay, so for our models today, we're going to start with 3D sketching and have some kind of teaser preview shots of what we're going to be doing. And as we go through the models, I always find it's a little bit more interesting model having a little bit of story behind it. So this first model here, this is actually something that has been made, and I'm going to be using that kind of as a demonstration of 3D sketching in SolidWorks. Actually, before I even get into that, is everyone here already familiar with 3D sketching, surfacing, and simulation? Anyone use all 3 of those tools already? Raise your hand. Does anyone use all 3 of those tools already? And it's very often on the nose. A lot of us. So for our first model here, this is actually something that's been made. So this is kind of the part that I want to show. And just for context, if you guys see in our markets, they build like core systems, they can put like the back of a pickup truck or in the trunk of a car. So I wanted to build one of those for my car, basically organize all that going on camping trips for hiking or something like that. And I was looking online and I saw I was like, I could build one of those with like colors that have way cheaper. So much more money, so much more time. But I got exactly what I wanted and it fits perfectly with my car. So it was a fun project. So that's what it is. There's only a drawer left on the left side right now. On the right side drawer. That's me. Parking lot, same thing, $20. Okay. So that's kind of what we're going to be building here is that we're not going to be worrying about the flood in the drawers. Just kind of this 3D sketch here and how 3D sketching works in SolidWorks.
Which is perhaps unsurprisingly going to be very, very related to 2D sketching in SolidWorks. So if you've already worked with 2D sketching in SolidWorks, which I'm assuming if you've worked in SolidWorks, then you've already done a fair amount of 2D sketching. Then you'll see that a lot of the fundamentals of sketching will carry over to 3D sketching. It's just in 3D sketching, the highs are high and the lows are low. So if you're not solid at 2D sketching, you're not good at the fundamentals of 2D sketching, you're going to be punished for it much more harshly in 3D sketching, and vice versa. If you're good at 2D sketching and you're good at kind of creating your design intent and moving efficiently through your sketch, that's going to pay dividends in a 3D sketch, right? There's an entire extra dimension that we can play with here. So ignoring kind of all these features, this is all kind of 2020 aluminum extrusion. We just go back here to the core of the model, which is invisible, but okay. We go back to the core of the model. This is kind of what it's built on, and this might be a relatively simple 3D sketch example for you guys. I try to start things out a little bit slower, so if you are a little bit bored at first, that's the perfect pace. I don't want to jump in right away and kind of just start slamming a bunch of stuff onto the screen, and then it's going to be really confusing, really frustrating. So it's going to be a little bit slow at first, but basically we're just working with a purely orthogonal 90-degree angles, not a lot of kind of fancy shapes or dimensions going on. So everything here is basically just an amalgamation of 2D sketches all stitched together into a 3D space. And this is a pretty big mess right now. Let me get rid of some of these. But this is the overall frame that I want to design. And I just want to show the finished product first. So the depth of the trunk is going to be 36 inches, and then the width is 40 inches. And I also have like the height in here and how I want to allocate the drawer space. So, excuse me, I just wanted it to be 50-50, but potentially in the future, if I were to remake this, I could easily make it, 10 inches on one side, 30 inches on the other, if I had some kind of larger drawer that I wanted to put in there. So
Really quick, I want to give kudos to Kenny. He had his relationships on in the 3D sketch. By default, they're off. Okay, he obviously had those on so you could see what was going on. And that's one of the many penalties of being in a 3D sketch that'll get you hard. Is if you're used to seeing those flags and they're gone. Sorry. Go ahead.
yeah, no problem. I'm actually just doing anyway. So, okay. So if I jump over to a fresh part here, I'm going to basically try to recreate that frame. And as I'm recreating it, I'm just going to talk about some common hangups and ways we can get around them while we're working inside of a 3D sketch. So as we just mentioned, you do want to have your relations turned on. So that's this item right here, view sketch relations. And honestly, I don't see a reason to ever turn this off unless your name is Kenny and you're giving a presentation and all the relations are basically clogging up your screen. Most of the time, or maybe not even most of the time, basically all the time, I want to know what my relations are because that's how my sketch is built, right? That's half of what I'm using to hold the sketch together. I have relations and I have dimensions. I'm not going to try to make a salad with just my right hand. I need kind of both sides of the coin here to hold my sketch together. And especially so when I'm working in a 3D sketch. So to get started, we're just going to go up to our sketch button, just like normal. And just below that, we have our 3D sketch button. And as I enter the 3D sketch mode, it's going to pop up my little origin in the middle, and then we'll get our confirmation corner in the top. So it's a very similar workflow to 2D sketching. But you might notice that we're not going to have any auto rotation normal to our sketch plane because there is no sketch plane here in a 3D sketch, right? So normally in a 2D sketch, I'm sketching on the top plane or the right plane or the front plane or face or something else in my model. Here, I'm just sketching in three-dimensional space. And as I start to kind of create my frame, so if I activate my rectangle tool, first thing you'll see is I get my normal pencil so I can make my rectangle like normal. And if I just blindly make one, right, it's going to look and behave just like a normal rectangle. Before I even click my mouse and try to start creating sketch geometry, probably one of the most important things you want to look out for, kind of like the low-hanging fruit of it, you're going to ignore everything I say and just pick out one thing, is going to be that XY that's by my pencil. So when you're inside of a 3D sketch and you activate a sketch entity, so whether that's a rectangle or a line or a circle, whatever tool you're using, usually by default, it will tell you that you are on the XY plane. So it's basically going to make your sketch as if you are in a 2D sketch and you are aligning it to the XY plane. That might be what you want, in which case you are good to go. Just make your rectangle and ignore what I've said. Or that might not be what you want, in which case you need to hit the tab key on your keyboard, and it'll switch to YZ. Or if you hit it again, it switches to ZX. If you hit it again, it switches back to XY. So this is, it seems like a small thing, but this is probably one of the biggest time savers of 3D sketching, is to just create your geometry in the location where it should be, right? It doesn't have to be exactly the right spot, but if I want something on the XY plane, I want to sketch it on the XY plane. Or if I want it parallel to the XY plane, I want it to be on the XY plane. I don't want to have to change things and kind of flip them around in 3D space if I can possibly avoid it. What you're going to find out, or maybe what you've already found out with 3D sketching, is it sucks moving 3D geometry around on a 2D screen, right? We don't want to be doing that as much as humanly possible. So I want to kind of put everything in approximately the right place before I start trying to drag an XYZ with my mouse on a 2D screen. It's very annoying. So for my first rectangle, I do want this on XZ. So I just hit my tab key a couple of times and then I get to, or it calls it out as ZX. And I'll place this on the origin. I'll just go out a little bit. And the first thing I'm going to do before I even continue with the rest of my sketch, I'm just going to dimension this right away. Technically in SolidWorks, when you dimension your first entity, I believe this setting is turned on by default. It should scale your sketch so that if this is supposed to be 1 inch or it's supposed to be 100 inches, the whole sketch doesn't shrink to nothing or explode out of the screen. Sometimes with 3D sketching, that can be a problem where if I make, let's say, my entire frame with no dimensions and then I dimension it, it can get a little hung up and it will explode your whole sketch and it'll break a bunch of things. It'll kind of flip things inside out. So before I get too far, I want to put down just the dimension that I know is going to be at preferably right or at least close to right. So in this case, it's supposed to be 40 inches wide. So I can put this in here. And in this case, when I put in that 40, nothing flips out on the screen. So it did scale it correctly. From experience, that will not always happen. Sometimes when I put in that 40, the whole thing will fly out of the screen or fly inwards and be invisible. So I'll just do the other side here. Okay, so it's 40 by 36. And then I want to basically create the other level of my frame. So I have kind of the bottom of my frame and I have the top of my frame. And this is where I need to start moving away from my origin, because this first rectangle, I was able to just slap it right down the origin, which is effectively placing this on the top plane. So you can see we're gonna be lined up right there. So I didn't really have to do anything special there, but at this point, I'm gonna either have to go up in the Y or down the Y, depending on where I want my origin to be in the model. Do I want it to be at the top of my platform or at the bottom of my platform? That's a design decision that is up to you guys. But in this case, let's say I want to be, the origin is at the bottom of my platform. So I need to place another rectangle parallel to XZ, but above this existing rectangle. And to do that, I have a couple options. So one, I can try to just make another rectangle and I can have it parallel to ZX and place it there. And you'll notice it's going to be kind of in the same XZ plane, which isn't bad yet. But let's see if I try to move this upwards in Y, I can connect these with a line here. And when you're using entities and you're snapping to other things. So right now I'm using a line, I'm snapping from one corner of my rectangle to the other corner of the rectangle. So this is going to be like one of the uprights of the frame. When I do that, it doesn't matter what the little letters say by my mouse, whether it says XY or ZX or YZ. When you snap to items, that will override whatever those letters say. And if I attach these lines together, I can see, okay, that corner's on. This corner won't move because it's already fixed. What I can do is I can grab this line and I can try to make this a long Y. And I can do that. And then the whole frame kind of just flips like that. So it's a little bit annoying. I could come back in here if I was persistent and I could maybe, cast another line down here. It's like I'm capturing an airship. I need to pull it down to the ground. Make this one a long Y as well. And it's going to try to just resist me. It's trying to basically move the sketch geometry into a position that satisfies my relations. And if I turn those on there, well, can anyone see what any of those relations are? I can't from back here. I just see green. Okay. Second scenario for when you want to turn these off is when everyone's too far from the screen to make them useful. Okay. So in this case, it's just trying to move the geometry as little as possible to make my relations and my dimensions true. So I said this line is long Y. I said this line is long Y. Technically right now, those are both true. This is just not the shape I want to make. And I can keep on going. I can basically put these lines on all the corners and eventually drag this down and put it in the right spot. That's gonna work just fine. If you want to do it like that, there's nothing technically wrong with that. It's just going to be a little bit slow, and for bigger sketches, that might become prohibitively slow. So another option that we can take advantage of is a 3D sketch plane. So rather than trying to stay in our 3D sketch environment the whole time, we can basically go back into a miniature 2D sketch while we're inside the 3D sketch. And to do this, I can use this plane tool. And defining a plane here is very similar to defining a plane elsewhere in SolidWorks. I give it a reference. I say I want to reference this from the top plane. And this is going to be the height of my my drawer system here. So I'm going to say this is going to be 9 inches away. by default, it pops up in the Y direction. I could go in the negative Y direction, depending on how I want to lay out my origin. But once I create that plane, what it will do is it automatically places me inside that. So you'll notice right now there's a little kind of grid pattern inside that plane. And if I hit Control-8 on my keyboard, I can go normal to that plane. And at this point, I'm effectively backed into my 2D sketch environment. And one of the telltale signs of that is if I make a rectangle, let's say I make a rectangle here, and I'll try to snap it to these corners here to save myself some clicking. And I look at the relation here, I can see that for my relations, it's making them perpendicular and parallel. And then for my options to add relations, I have horizontal and vertical. Horizontal and vertical are not going to be normal options that you see inside of a 3D sketch environment. And to show that here, to get out of this sketch plane, I just double click into some empty space. So I double click out here. So I'm now back into my normal 3D sketch mode. If I try to select one of these lines down here, you'll notice that I can add a relation to it, but my options to add to that line are along X, along Y, and along Z. So just something to keep in mind. It seems like a small thing, but if you're looking for horizontal and vertical, you're not going to find it unless you're inside a 2D sketch plane. So along X, Y, and Z are kind of the stand-ins for horizontal and vertical when we're working inside of a 3D sketch, unless we have a 2D sketch plane. So to go back to that plane, I can double click on it, and then you can see it gets that little cross-hatch pattern. And now for these lines here, I can make it horizontal or I can make it vertical to hold in position. So it's kind of reducing the complexity of this back down into my 2D.
Back up what Kenny is saying. At one point, we couldn't mirror in a 3D sketch. You had to be on a 2D plane in a 3D sketch in order to mirror anything.
Huh. That's one of those things where you don't know until you run into it. I didn't know that. No. So with these lines here, once I get out of that 2D mode, I can just cast my same lines down from the corners. And as I do these ones, they should automatically pick up an along Y relation. So similar to 2D sketching, where if you make your line close to horizontal or if you make your line close to vertical, it will pick up the corresponding relation. The same thing happens here with along X, along Y, and along Z. So you'll notice now, after I've created those lines, they show up in black, and then also the relation here from says along Y. So it's automatically picked it up because basically the geometry was in a position to allow it to move straight along the Y-axis, therefore it picks up that relation. So that's kind of the overall shape of the frame. And then the other thing that I want to add in here, we're going to be some cross members. And actually, if I go back a second here, and let's just scroll down on this, just to get some more context as to what we're doing. So I want to put some lines in to basically represent these cross members here. The reason is that if you remember from the picture, I have some little wood planks going across this in the Z direction, and they're not strong enough or they're not stiff enough to kind of make that whole span on their own. So I just want to put these two members in, and I want them to be equally spaced. So inside my 3D sketch, I can make my line, and I can just make it in approximately the right spot. And I'll do my second line over here. And again, as I'm making the line, I can snap it to along X. So if I click on one of these lines now, I can see it has picked up that along X relation. Same thing for the first line there. And let me move that dimension. Okay. And then the only thing I have remaining for these lines is to basically define their position fore and aft in this Z direction. And hopefully this is an easy choice for you guys where you do not want to use your dimension tool for this. What I don't want to do, and this is going back, not even in 3D sketching, but back to 2D sketching, I do not want to do something like this. I don't want to dimension my members 12 inches and 12 inches. All right, so this is just basic design intent here. It's just going to be more work to fix this in the future. if I bake bad design intent like this into my part, compared to if I were to do this in something like a 2D sketch. So anytime I'm doing math in my head in SolidWorks, I'm usually doing something wrong. There might be some very complex occasions where you do need to do math, but if I'm kind of deciding the spacing for this, there's going to be 3 spaces. I'm doing 36 divided by 3 is 12. If you're doing math in your head, 99.9% of the time, there's a better way. So what I want to do is just want to set up some construction geometry here. And this is something else that I wanted to mention with 3D sketching is the importance of construction geometry. So you're likely already familiar with the use of construction geometry inside a 2D sketch environment. It's especially useful in a 3D sketch environment just because all our entities have so many more degrees of freedom, right? So a point in a 2D sketch has 2 degrees of freedom. It can move in the X direction and it can move in the Y direction. Whereas that same point in a 3D sketch now has 3 degrees of freedom. And as we expand the complexity of a sketch and add more and more entities, degrees of freedom can very quickly get overwhelming. So construction geometry is going to be very helpful for that. So what I'm going to do is I'm going to set up some construction lines here. And there's a couple different ways I could do this. What I'm going to do is I'm just going to make a line, attach it to the line here. I'm actually going to make these intentionally crooked. This is something that I'll often do in all my sketches, not just 3D sketches, just to double check that as I add my relations, I'm adding them correctly. This first line here is pretty close to the right orientation. And if I add my along Z, you can see it moves very slightly. But if I have it in almost the correct orientation, then I add the relation, I don't get as much visual confirmation. That's just something I personally like to do, just to kind of see it snap across the screen. So I know, okay, this has the along Z relation, or this has whatever relation I need to make sure it's correct. So I can do that for all of these entities here. So make them all along Z, and then I can just grab them here and add an equal relation. And now I'll just equally space them. That way, in the future, if maybe I want to make one of these for my friends and their trunk is shallower or deeper than mine, I need to change this here. Let's say they got a big old car, it's 48 inches deep. Then I can change that dimension and those crossbars will automatically stay spaced out. What this won't do though is modify the number of crossbars. So right now I'm stuck at 2 crossbars in the middle. And it'll just adjust the spacing for them automatically. If for some reason I were to make this some huge number, then kind of the span between the crossbars might again become problematic. So it's limited in what it can do, but I can save myself a lot of headache in the future if I just don't take shortcuts and set this up with the correct design intent. So a lot of 3D sketching is going to be similar to 2D sketching. It's just those planes are being added in, then we have a long X, Y, and Z. Just if you make a mistake in 3D sketching, the consequences are much more annoying compared to a 2D sketch. And if I put this back here, well, size doesn't really matter, but I'm just going to put it back in. Something else that I want to talk about, and this is a little bit more subjective, with 3D sketching is becoming a little bit more comfortable with underdefined geometry. So if you're like me, inside a 2D sketch, I'm basically always fully defining my sketch, unless I'm just doing like a throwaway test sketch that I know I'm going to trash at the end of the hour or something like that. So I'm not saying that you should just go and create underdefined geometry in your 3D sketches, but in my opinion, it's a lot more acceptable to have underdefined geometry in a 3D sketch than it is in a 2D sketch. For instance, right now, these lines here, if I try to grab it, they are underdefined, and I can drag them basically back and forth in this X direction. So that's causing my sketch to show up here as underdefined. If this is something that is going to bother me, or maybe if you have some kind of company standard, maybe some kind of like automatic design checker that's going to be looking for underdefined sketches, then by all means, you can go ahead and snap this into some position. You can maybe leave it here right in the middle. All right, and now it's fully defined and it's not going to move anywhere. But it's important to know kind of where to spend our time and effort, because we don't have infinite time and we don't have infinite resources when we're working on every project, even if we might want to have. So I'm not going to sit here and worry about the exact position of this construction geometry if I have, you know, 5 projects in my backlog and it's Friday afternoon.
At
Right.
the same time, though, I wanna take you to task here. If you don't fully define everything and it says underdefined, and you don't know what's underdefined. That can be a problem too, and that could take you longer than.
It is.
Right to begin with.
It is a problem if you don't understand what's underdefined in your sketch. So for a simple example like this, when I see this message down at the bottom and it says underdefined, technically anything in the sketch could be blue and it could be really small and invisible, and I'm not going to know what's underdefined. For a sketch like this, it's a lot easier for me to see this is my blue geometry. And right before I made this, I was also able to see that the sketch is fully defined. So I know that these are the items that are defined. I don't have like some random, little corner down here or something like that that's just floating around, dangling in the wind, sitting as underdefined. So it is going to be a little bit harder to kind of have this leeway if you have a more complex sketch and you have lots of entities floating around. Then yeah, it might make more sense to kind of leave all of your construction geometry in some specific location. Maybe put it in the middle, maybe put it off the side, wherever you want, right? The position, this doesn't matter. What matters here is these 3 equal lengths that are keeping the crossbars kind of equally spaced out in the model. So that's not a hard and fast rule. And if you guys have the time, by all means, please fully define your sketches, regardless if they're in 2D or 3D. But I think it is a worthwhile pursuit to stop thinking about a lot of things, but especially SolidWorks in terms of absolutes, saying that you can never have an underdefined sketch. Everything has to be fully defined. It takes a lot of the decision-making, the nuance out of the design process, in my opinion, as an engineer or as a designer. Some things don't need to be fully defined.
And because everybody has opinions, I'm gonna say always fully defined, never delete, it'll be your best friend. Yep.
So with my frame here mostly complete, there's a little crossbar in the middle that I'm going to skip over for now, just so we can cover a few more topics. Something else I wanted to show were splines in a 3D sketch, and kind of paralleling what I've already talked about with this 3D sketch. The sketching environment is going to be very similar to a 2D sketch. It's just more punishing and more degrees of freedom compared to a 2D sketch. So I'm working with splines in a 3D sketch, and actually, here we go. So this is a kind of model I just set where I have some random points and I want to create some kind of spline through these points. What I can do is with my 3D sketch tool, using a spline, I can just go through these points, and as I attach to them, the spline will basically travel through all these points. And let's say I just want to go through the red path here. Then I'll stop there. So I can make my spline and it'll just go through all those 3 sketch points. And by default, it'll actually show up here as fully defined. And let's see if it will allow here. So what I can do is basically grab the handle of my spline and move it around, even though it says that my spline is fully defined. So if it wasn't already controversial enough, we're going to add some more fuel to the fire of the fully defined versus underdefined debate with 3D sketches. Splines are going to be very, very unruly in 3D sketches. You'll often get behavior like this where it'll show up as fully defined, but you can still come in and drag it.
And I will agree with Kenny there, and I'll also say in 2D sketches, splines are a pain in the arse to fully define. In which case, the best practice is to make a block out of it. And then locate the block, and then you'll be fully defined again.
So that's another question I had. So this sketching tool is the same as what's in round, right?
Yes,
So I have a question that I have is, planes, modify the planes into sketch planes.
Mhm.
Can you do those in relation to an assembly and you sketch mode? Like you can't with. Can't, okay, I don't use. it. So I don't use
Like if you're making a 3D sketch inside assembly to do routing.
it. Reference planes.
Hmm.
Why?
If it's piping and tubing, then I recommend doing straight lines and then doing a fixed line. And then making your tolerance based on the elbows.
Another option here with their splines, which is sometimes overlooked just because you have to go through an extra menu for it, is rather than using a spline, using a style spline. So style splines are a little bit easier to work with just because rather than defining the explicit locations that the spline is passing through. So notice here, I'm going to go through the red path again. As I click on these corners, the spline isn't actually going through those points except at the beginning and at the end. So the first point I click on, the spline starts there. The last point I click on, the spline ends there. But in between all of these points, they're basically, I kind of just imagine them as like 3D spline handles that kind of influence the path the spline takes through space. Right now it's showing up as underdefined. This is another quirk here of 3D sketching. Oftentimes, snapping geometry does not work as well as you would think it would. So trying to snap something to a point, for instance, when I made this style spline, I was trying to snap those handles to all those points. And it was kind of highlighting and moving my mouse over as if it's snapping, but it doesn't make a relation. So a lot of times in a 3D sketch, I'm gonna have to go back through and basically I can lift my point off because it's effectively just a positioning snap. It's not actually making a relation. But if I lift it off and then I place it back, then let's see here. It's a little finicky. There we go. Then it'll snap. So oftentimes just the viewing of your sketch, depending on the angle you're going at, will stop the point from attaching to the actual corner that you want or the geometry that you want. So something to keep in mind there is when you're working 3D sketching, either be careful with your snaps and try and double check them. So here I just snapped this corner. I'm going to double check my work. If I just try and drag it, it's not going to move. Or another option is rather than relying on the drag functionality is to just go back to your normal control clicking and use that to make them coincident. So something to keep in mind there.
For those that have never used style splines, those points that he was attaching could be thought of as the control polygon on a regular spline.
And then with these style splines, an obvious restriction not just go through these points. So in between here, I have no kind of formal definition of where the spline is. Like, what are the XYZ coordinates of this point? If I want to try to force it through some specific area. A quick workaround that you could do for that is you could basically break up your style spline. So if I wanted to go through these points, rather than making one single style spline, you can break it up and basically create, let's say, a style spline for the green section. I'm not going to snap those points just for the sake of time. They are in the right spot. They're just underdefined right now. But if I do the same spline method over here for the blue section, then I can basically force the spline through any arbitrary point by just stopping and ending the spline at that point. So it's going to be a little bit more work. If you do need your splines to go through an exact point, then it may be better to resort to the spline tool versus the style spline tool. It's basically a trade-off of, do you want explicit control of where your spline is moving, or do you want your spline to be easier to fully define? With all these splines, it is an option to just go to the spline itself and just add a fixed relation, which is that little boat anchor icon that basically just glues it to the background wherever it is. That will make your sketch fully defined. So if I do the same thing for this last spline right here, right, I can kind of glue it into space wherever it currently is. And then my sketch indicates fully defined, but still don't have any, dimensional relation saying where that exact point is. It's basically just to stop someone from inadvertently coming in and maybe dragging my spline by accident while they're trying to modify something.